why don't you go to the seaside and sit whatever at the seaside and have a drink at the swimming pool? And I said, that would be so boring. I mean, seeing the Eastern Sea, that would be interesting, but then I would stand there and look at the waves for hours. And so I think going to the city was a better decision. Okay, good. So go. Okay, let's get started. And let's get started with a simple question. And let me a simple question. How do you think people will react in terms of saving when the interest rate goes up? Do people save more or do they save less?
They will save more.
Yes? Can you tell me why?
So it's worth more to put your money, in the saving account because of the high interest.
Mm-hmm.
And also because high interest, so it costs more for you to borrow, right? So it's kind of like
Mm-hmm.
way.
Okay. Now, I'm glad you're saying that because that's what most people would say. And now let me show you that things are a bit more complicated. And this is one of the most important things to take away from this because, I mean, you're doing international macroeconomics with me, but you're also doing macroeconomics with other people. And saving is one of the key things that because consumption is related to saving. Now, the bottom line is, and that's why I'm bringing it up, the relationship between the interest rate and savings is a complicated one. And let me show you why. Now let me deviate from the script and let me present you a simple, but I'll come back to my overlapping generations model. Suppose interest rates and saving in a two-period model. Okay, so case 1, income only in period 1. So the idea is you have someone who gets who lives for two periods and gets an income in the first period and has to decide how much to save. So the optimization problem is maximize U1, and I'm specifying the utility function as being having a constant intertemporal elasticity of substitution. And the constraints are C1 equals Y1 minus S1, and C2 is 1 plus R S1. And S1 is savings in period 1. Okay, how do we solve that? We solve it by substituting the constraints, how do we solve the optimization problem? We solve it by substituting consumption when C1 into here and C2 into there. So this is equivalent to saying maximize U1 equals Y1 minus S1 to the power of 1 minus sigma minus 1 over 1 minus sigma plus beta 1 plus R S1 this. Okay. I'm not asking because I know the answer. What do economists do when they have nothing else to do? They take derivatives. The question is, with respect to which variable do we take derivatives? Exactly. So choosing saving, so you've transformed, I mean, we could have written this down as a Lagrange function with two constraints, but the easier way is just to substitute this in here and this in there, and then we maximize subject to, so with respect to S1. So we choose savings optimally, and once we've chosen savings optimally, this is this gives us consumption period 1 and period 2, because consumption, the more we save, the less we consume in period 1, the more we consume in period 2. Now, what is the first order condition? Well, the first order condition is y1 minus s1 to the power of minus sigma plus beta 1 plus r s1 to the power of minus sigma. Oops, I forgot something important. Let me add it here, right? The minus is important because we have the minus there. Times 1 plus r, and that has to be equal to 0. Okay, let me check my. So this is equivalent to saying y1 minus s1 to the power of minus sigma equals beta 1 plus r 1 plus r s1 to the power of minus sigma. Well, that in turn, if we want to get rid of these folks here. Hi, good morning. We want to get rid of these. Hi, good morning. Good to see you. Okay, we have y1 minus s1 equals beta to the power of 1 over sigma, 1 plus r to the power of minus 1 over sigma, 1 plus r s1. Okay, now you see that we have the S1 here, and we have the S1 there. So we want to factor out S1, and we get y1 equals S1, 1 plus beta to the power of minus 1 over sigma, 1 plus r to the power of 1 minus 1 over sigma. Now this thing here, let me use the red pen. This is sigma minus 1 over sigma. Okay, now we're done. We have savings in the first period is y1 divided by 1 plus beta to the power of 1 over sigma, 1 plus r to the power of sigma minus 1 over sigma. Now, this is an important result. And I give you some okay. Now, let's use this part of the whiteboard to look at if y1 goes up, what happens to savings? Right. So if people have more income,
they tend to save more.
they tend to save more. Actually, or interestingly, note in this model does not depend on y1. This is exactly what is implied by the constant intertemporal elasticity of substitution, the constant intertemporal elasticity of substitution utility function, right? If you divide by y1, you see it's the share of their income that people save does not, in this model, does not depend on people's income. Is this realistic? The answer is not really. This is an important, so the constant intertemporal elasticity of substitution function is all over the place. One implication is that the savings rate of poor people is the same as the savings rate of rich people. This is something